Hi everyone, welcome to the introduction of the Open RAN online course. For those of you may not be familiar with Open RAN, it is a new technology that's been gaining a lot of traction in the telecommunication industry over the past few years. So it's a very new technology, just like what Sir Herbert told us earlier from his presentation. Open RAN is all about breaking down the traditional closed and proprietary systems that have dominated the industry for decades. So it's been the just like what you also said that the current architecture of the RAN today is the traditional RAN. So the Open RAN is a new technology that is about to come. So instead in the Open RAN, it is open and interoperable networks that allow for greater innovation, flexibility, and cost effectiveness. So we will be taking you deep dive into the world of the Open RAN, exploring its history, key concepts, principles, and practical application in the real world scenario. So maybe a lot of you are from the telecom professionals, students, or just curious about what is an Open RAN. So without further, let's start or let's begin. So this will be all the topics which will I be discussing in today's session. So first we have is the introduction to RAN. So we will be going back from its roots for us to be more knowledgeable or equipped to what is an Open RAN, so we can better understand what is the Open RAN. So we need to go back to its roots or the history or from the beginning. So next is the RAN and OSI layer. It is a very important topic that we need to be more knowledgeable in the application of Open RAN or in telco. Next is what is 5G. It is how do you say this? It is the implementation or it will be implemented in the Open RAN, the technology that will be implemented in the Open RAN. Next is the RAN architecture. What is an Open RAN? So this will be our focus. The GPP hardware and open systems, the Open RAN ecosystems, the deployments and trials, and some key learning points that will summarize all of the discussions that na i-discuss ko today. So let's start. Whew. So maybe most of you are familiar with the radio access network. So first, let's define what is a RAN. So these RAN are commonly known as the cell sites in layman's term, but in the engineering field, we call it as the radio access network. So this RAN is strategically placed to provide wireless coverage to users within a specific geographic area. So the placement of these RAN components, such as cell sites, is a very critical job to ensure that the users have reliable and consistent access to the network services that they need. So when planning the deployment of a RAN, network operators consider various factors. So um, this can be first of all is population density. Next is building density, um, topography, wait, topography, traffic patterns, sometimes weather, and a lot of other factors that we need to consider in placing or planning this radio access network. So if we critically analyze all of these factors, network operators can determine the optimal location and configuration of RAN components to like ensure maximum coverage and capacity. So that is the goal, to give our users the maximum coverage and capacity. So for example, let's say that we are planning to install or build a radio access network in some urban areas. So it's expected that these urban areas have higher population density and building density. So us, the engineers or the person who's behind in the planning of the radio access networks, may opt to deploying more cell sites in this kind of area, and applying lower output power to provide coverage to smaller areas. At least if kahit na small lang yung area na na-provide natin, we can still give them the goal of giving them a maximum coverage and capacity. So what about if we built it in some rural areas naman? So it's expected that in rural areas there are lower population density. So in this kind of areas, we may need to deploy fewer cell sites with higher output power to provide coverage to larger areas. So that's how we build and plan um, in deploying this radio access networks. Okay, so the placement of a RAN is components also affects the overall network performance, such as the call quality, data speeds, and network capacity. So if we strategically planned on placing kung saan natin ilalagay itong mga radio access network na to, we can optimize the network performance and ensure the users that we're giving them a high quality and reliable network experience. So here, as you can see on the screen, we are deploying a lot of radio access network, to be specific here in the Philippines, and it creates a seamless coverage and mobility. So good. So here you can see on the screen overview of a mobile network coverage. So just like what I've said earlier, we strategically place across a geographic area these RAN, so we can ensure them that mobile devices within the network coverage area can connect to the RAN and access network services. So it is the reason why your phones have signals, why you can connect to the other side of the earth or somewhere. So these radio access network connects mobile devices network and thereby offers mobile network coverage. So take a look on this how you call this on this figure. So in this figure is an example of a mobile operator's coverage. So as you can see here, the operators are using a color-coded system to illustrate which technology. So these are the technologies that I am saying, the 2G, 3G, 4G, 4G plus, and 5G. So these are what we call the technology. So these color codes represents each technology. So we can easily distinguish what is the existing technology in each side. So some locations here have still 2G and 3G, but majority of the locations is covered by 4G. So surprisingly, we can see here 5G technology. So it's a good thing because operators have already deployed 5G technology in most areas of the country. So the location and distribution of the RAN facilities are critical, just like what I've been telling you, to the mobile network coverage. For us to have seamless seamless coverage all throughout kung saan man tayo pumupunta. Okay, so now we will be talking about the wireless telecommunication system components. So this is a simplified or the illustration, how we will illustrate the wireless telecommunication system components. So we have here the user terminal. We also call it a user equipment, a mobile station, Next is we have here the radio access network. And third is we have here the core network. So these three are the main parts of a wireless telecommunication system. But first, we have to define all of these three. So here we have is the user equipment or the user terminal. So if you're listening from Sir Herbert earlier, these user equipment is in layman terms are the mobile phones that we are using or any device that is connected to the network. So so it some example of these user terminals can be your smartphones, tablets, laptops, and other devices that can be connected to the network or that are equipped with connectivity features such as Wi-Fi and Bluetooth. So these user terminals are communicating with the radio access network, which is the second part of our system. So they are communicating via airwaves or air interface. Um, how do you say this? These airwaves use different frequencies, which we call the radio frequency. So, so you need to take note of that. So next, we have here on the other side, we have here the radio access network. So this radio access network is responsible for providing the wireless connectivity required for the mobile devices or the user equipment to connect to our core network and access these services. So these RAN includes all the cell sites. Each of these cell sites have its base station that communicates with the mobile devices via airwaves, and it has different components which we will discuss later in this session. Okay. So next, um, after this RAN, lastly we have the core network, who is responsible for managing the overall routing between the different networks and providing advanced services such as voice, calling, messaging, and data services. So these core network is connected to the RAN via a backhaul. So these backhaul have different means of transmission. So as you can see here in the illustration, we have here a microwave, fiber optic, and the satellite. So these microwaves, it is used for wireless transmission. For physical transmission, we can opt to using fiber optics. And if if the site or if the location has a very challenging terrain or is being limited by the curvature of the earth, we opt to using satellite. Most likely, this core network functions, you can see as the brain of the whole system. Here is where sabi ko nga kanina, it covers all the uh, managing of the overall system of the core of this system. So this is where all the calls, messages, and data or information were being managed. So now let's focus on the radio access network. So mobile network coverage comes from a radio access network. So lahat ng signals na nadedetect ng po natin comes from the radio access network. So this RAN is a part of the cellular network that is nearest to the subscriber. So you can see a lot of RAN all around you kahit na just like what this all saying that the location is widely distributed kasi nga you can see it everywhere. You can see it in some cities, villages, highways while traveling, rurals, on the top of the hills or hills, beaches, malls and offices. So this is widely distributed so we can create a seamless coverage and mobility. So technically, RAN is all around you. But let's say, have you ever stopped to think about how your mobile device is able to connect to the internet and make calls and texts while you're on the road or outside of your house? Have you? Um, I think we have to be grateful and thankful to the RAN because of these radio access network. We can connect everywhere. We can connect to our friends and families even we're out of our houses. So next time na you're out of your house, you can look around you and open your third eye, we call, and like you likely see a lot of radio access networks. Radio access network. So most likely you can see it everywhere. If you're in the city or urban areas, you can see it on the top of the buildings, alongside of all the roads. If you're on a tour, you can see a lot of this. It might be off on a hill. If you're in the city, you can see it again in the rooftop or the roof decks. Here you can see here. Besides everywhere. Next is, but not all runs are outdoor. You can also see some run indoor. So as you can see here, uh, you can see here a small device. This small device is a part of a radio access network. So it is more like the small cell. It is mostly mistaken as a Wi-Fi access point, but this is a part of a RAN that giving you signal inside of a building or a mall. So the RAN enables you to stream music, videos, stay connected with friends and family kahit na nasaan ka. So hindi lang siya limited around the city or towns, but extended to rural areas, highways, and even in some remote locations. So it's making possible for everyone around the world to connect, to stay connected. But before moving forward on the discussion, we will first discuss. No, we will first discuss the same RAN. I will be sharing to you the indoor system of a RAN. So in an IBS design or in building solution, we have a RAN. So it's different from the RAN that we see outdoor. All the RANs that we see outdoor is on the tower, but the system of the RAN inside a building looks different, but uh, have the same principle and functions. So here we have the main components of a RAN. These main components have the remote radio unit, the baseband unit, the cabinet, and the battery. So most likely, we place the radio room we call um, at the ground floor of a building. Sometimes if there's no available space at the ground floor, if there's an available space outside, we build a cabinet or a cabin to build a RAN inside the building. So from the radio cabin up from the radio room, we will use a lot of cables, splitters, sometimes couplers to deploy different antennas that will give you access or that will give you coverage inside of a building. So that's what's happening inside an indoor system radio access network. So, but first, I will be discussing you the evolution of a mobile communication. So, can you imagine a time when mobile communications or mobile phone didn't exist? I think that's not too long ago, but that we are limited to just using radios and landline telephones. It's like we're waiting for our loved ones to call for hours beside the telephone. It's just like some some movies that I watch because I was born with existing mobile phones. But it all changed when the first generation of mobile communication entered in the picture. So the mobile telecommunication was was introduced during the 1980s. So it is the first mobile technology and use analog signals to enable basic voice calling. So it's all calls. So these early mobile phones were large and expensive, as you can see here in the picture. So it is expensive also, and the network coverage of these phones is somewhat very limited. So, but these first generation leads us to the foundation of the mobile communication that is about to come. So here leads us to the introduction or the evolution of the next mobile communication, which is the 2G. This is introduced to us during the 1990s, so it's after 10 years. The 2G exists and is still existing nowadays. Uh, it enables voice and text messaging services. So way back, I think texting was a trend back in the Philippines, and we, the Filipinos, are entitled to be the text capital of the world. Even me was one of those who loves to text back then. So yeah, that's it. So then there came the 3G, which was introduced during the 2000s. So again, after 10 years, we have the new mobile communication generation. It is the third generation. So it brought faster data, um, enabling more advanced services like multimedia, calling, video calling. Back then, we're not very into video calling, uh, because I think Filipinos don't like for them they're a very they respect personal privacy, so they are not into video calling by that time. So these three supported better voice quality and allowed simultaneous voice and data services. So it also the start of the success of the smartphones. Also back then pala, we already have a data during the second generation of the mobile communication, which I think the GPRS or the Edge, but it's not that fast as the third generation of mobile communication. Next is we have the fourth generation, which was introduced during 2010. So it brought even faster data speeds than the previous generation, a better network capacity, a more reliable coverage, which enable us to streaming videos, online gaming, mobile payments, also make a way for the Internet of Things and other emerging technologies. So this is what we're using at the present. And now, we are paunti-unti na ini-introduce na sa atin si 5G network technology. So in this network technology, it promises much even faster and even more capable than the fourth generation. It gives a data speeds that up to 100 times faster than the fourth generation. So the ability to support a massive number of devices, it has the ability to support a massive number of devices at once. So we will be tackling this later in this discussion. So this technology, it opens a lot of, of innovative services and applications for to transform the way we live and the way we work. So there you have it, the first generation to the fifth generation of mobile communication. So it really gives or brought us a major advancement in mobile tech. technology. So maybe in by next year or the next year we also have we can already have the 6G. That is one very trending topic to in today's in the present. So now each mobile communication have different radio access network, different names for the each um radio access network. So if you ever heard about it, maybe you have heard about the JERAN, the UTRAN, the EUTRAN, and the NG-RAN. So the JERAN, it is the GSM Edge Radio Access Network for the second generation of the mobile communication. While in the third generation, we use UTRAN or ano yan? UMTS Terrestrial Radio Access Network. So UMTS means Universal Mobile Telecommunication System. Next is we have here for the fourth generation, we have what we call the EUTRAN or Evolve UMTS Terrestrial Radio Access Network. And lastly, we have here for the fifth generation, the NG-RAN or the Next Generation Radio Access Network. So these are the different names for our RAN. So now we will be focusing more on the radio access network. So here is a simple illustration or a simple diagram for a RAN architecture. So we have here the core network. Here is the radio access network and the user terminal. So if you'll observe, these are based from the first illustration that we from the previous slide of the wireless telecommunication system. So the UE, RAN, and the core network. So in the radio access network, we have two main components. So we have there the RRU and the DBU. So let's see. So first, you'll observe from all the cell sites that you see around you is the tower itself. So here is the tower. So this tower is a physical structure that supports the RAN components. So dito natin kinakabit lahat yung mga components that we install on site. So this RAN consists of antennas, some RRU, different jumper cables, CPRI, the BBU, and the cabinet, which is below the tower. So this tower structure is designed to be sturdy and stable, even in high winds and extreme conditions. So there are a lot of factors that we considering in deciding on what type of tower is to be installed on site. So one is materials, and a lot more of computation, especially in the wind. There's a wind something computation that they're talking about. So, but for all of this, you can ask a civil engineer for this because they're the one who's responsible for everything that's concerning the tower or the main tower, and not us, the electronics engineer, the CS, or anyone. So next, looking back, so isa-isahin natin. Let's define each. So we have here the panel antenna. So the antenna system is responsible for transmitting and receiving radio signals between the mobile device or the user equipment and the RAN components. So the antenna system is typically made up of multiple antennas, as you can see in the picture on the screen, that are placed at different heights. So magkakaiba yung heights nila. to provide uh to provide coverage to different areas. Uh, we have different heights and types of antennas depending on the specification needed. So we have antennas with high frequencies. So this kind of antennas must be placed at the top of the tower for us to minimize losses and maximize the height so it can propagate much faster. Again, um, just like what I've been telling you, there are a lot of types of antennas depending on the specification, but we won't be discussing it in this session. So there are a lot of seminars that you can attend to in discussing on the antenna part. So the cables are here. The cables are another important of the component of the RAN system. So these cables are connect it connects the different RAN components such as the antenna, the RRU, and the BBU that you saw earlier. So these cables naman is typically made of coaxial cable or fiber optic material. So next is we're going to the two main parts of the tower or the radio access network, which is the RRU. So the RRU is a critical component of the RAN system. So it is a very important component of a RAN. So the RRU is responsible mostly for like converting the radio signals received by the antenna system so into digital signals that can be processed by the BBU. Okay, so we're back at the RRU. So again, so the RRU the RRU is a critical component of the RAN again kasi nga it's responsible for converting the radio signals into received by the antenna system into digital signals na pinaprocess naman ni BBU. So there are times that this the radio remote unit is located at the top of the tower near the tower structure. If you're going outside and observe some towers, you can see there na the RRU is located um, near the antenna. So I think most of the cell sites are designed like that. So we can minimize the losses, the cable losses on the whole system, on the whole antenna system. But also there are RRUs that are located inside the cabinet, inside a cabin. So this RRU is connected to the baseband unit via a CPRI, the Common Public Radio Interface. So this CPRI is the standard protocol used to transmit digital signals between the RRU and the BBU. So this cable ensures that the signals are transmitted quickly and efficiently without any loss or degradation in quality. So next, we have here another important main part of the RAN, which is the BBU. So it is the one who is responsible for processing the digital signals received by the RRU and transmitting them to the core network. The BBU is typically located under or below or on the bottom of the tower structure near the outer cabinet. This is the outer cabinet. So this outer cabinet has ventilation, power supply, and other components. So uh, this is the transmission component of the RAN system. So this includes the BBU, the RRU, antennas, cables, but also there's one critical component that a RAN has is the transmission. So here in the illustration, we have a microwave antenna going to the core network. So yeah, that's it. So next is here we are showing you an actual picture of what a radio access unit looks like. So in actual, this is what it looks like. So we have here the antennas. You can see here the antennas and the RRU. These are some cables. Same goes here. And here is the what you seeing is the cabinet. So this is what deployment of RAN looks like. So there's the equipment from traditional vendors that we're currently using at, right now is the CPRI. So again, the CPRI connects the RU and the VVU. So it is the one that used to transmit data between the RU and the VVU. So this cable or this CPRI enables the high-speed transmission of data over fiber optics cable. So it allows the RRU and the VVU processing unit to communicate with each other. And now we have here is the VVU. So VVU is a very, very critical component of the radio access network, as what I have told you. So because it is responsible for managing, processing the data that is transmitted to the core network. So essentially, in a radio access network system, the BBU serves as the brain of the RAN, controlling the flow of data and ensuring that everything operates smoothly. So this is a very important component of the radio access network. So now, after discussing what is a RAN or what are the different components of a RAN, we are now be moving forward to the RAN and the OSI layer. So the RAN system is divided into different layers. So each of which is responsible for a different aspect of the system. So one way for us to conceptualize these layers that I'm telling you is through the OSI or Open Systems Interconnection Model, which is a conceptual framework that describes the communication functions of a telecommunication or computing system. So the OSI model, in definition, is a set of concepts that describes and standardize how a computer or telecommunication system communicates, regardless of how it is built or what technology it uses. So you can see here the 7 layers of an OSI model. So I think this was discussed during your undergraduate studies. This is a very, very familiar topic for all of us. So we have here the 7 layers: the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. So this it's a lot to remember. But first, let me define you or tell you or let's have a recap or a review for what each of this layer is responsible for. So we have here a physical layer. So the physical layer here is responsible for the transmission and reception of a raw data over a physical medium. So this uses such cables as like copper, fiber optic cable. So that's the physical layer. So we have here the second layer, which is the data link layer. So this layer is responsible for the reliable transmission of data over a shared physical medium. So these are not using a physical medium, but using a protocols such as the Ethernet or the Wi-Fi. Next is we have here the third layer, which is the network layer. So this layer is responsible for routing data between different layers, uh, routing data between different devices on a network. So in a network. So this layer uses protocols such as IP or the MPLS or multi-protocol label switch. Then this one naman is the transport layer. It is responsible for ensuring reliable and efficient data transfer between the devices on a network. So this use of protocols such as the TCP or Transmission Control Protocol, UDP or User Datagram Protocol. Next is we have here the session layer. So it is mostly are responsible for establishing and managing communication sessions between devices on a network using protocols such as the RPC or the what is it? Remote procedure call or the net BIOS. So the next layer is second to the last layer, which is the presentation layer. So this layer is responsible for formatting and presenting data to be transmitted over a network. So it uses protocols such as the ASCII or the JPEG. And lastly, we have here is the application layer, which is responsible for providing high level services and applications to users. So it's more on the uh, emails, web browsing, and voice calling. So each of these layers really plays a critical role in the operation of the radio access network system. So it enables the different mobile devices for to connect to the network coverage and access a wide range of different services. So it's very important for us to understand each layer. So aside from that, it's very just like what I've said, it is a lot to remember. So we use 7 layers mnemonic, OSI model mnemonic. So it's all people seem to need data processing. Ah, so deep. But I think back in college, I am using do you remember? I'm using ang ano yun? Ang pulis sa tulay nadapa. Ang pulis sa tulay nadapa. So I think that's the mnemonic that we frequently we use back in college or back in the review days or in the review centers. There's another one pa eh. Parang that's please uh please don't please do not take Susan's panty away. So if you wanted in English, you can use that. Please do not take Susan's panty away. So you can use any mnemonics that you're more comfortable to remember this 7 OSI layer. So in the 7 OSI layer, um, there are 3 layers that is doing the RAN is doing the functions for the 3 layer. So it is the physical data link and the network layer. So it is done by the 2 main units, which is the radio unit and the baseband unit. So you have to remember that. So in a RAN, the RAN is doing the function for these 3 layers. So the physical, the data link, and the network. So take note of that. So as we map it out in a tabular form. So we have here the 3 layers. We have here the physical, the data link, and the network. So if we connect it to the RAN here, the RAN part, so these 3 layers are using different protocols. So we have here the RRC, the PDCP, RLC, MAC, and the AIR interface for physical. So yeah, that's it. So here we are now relating the both from the RAN and the OSI 7 layers. So we have here again same as same principle but presented in a different manner. So we have here again UE, the radio access network, and the core network. So, I think, tumatatak na sa isip niyo yung tatlong 'to, yung simple, illustration of the wireless telecommunication system. So, the UE, the RAN, and the core network. So, here we have is the UE, or the UE, which is connected to the RAN via air interface, and the core network is connected to the RAN via a backhaul. Now we're focusing in the radio access network. So in the radio access network, or the RAN, again, we have here the two main components of the radio access network and the antenna. So the antenna, here it is, the antenna. So we have different types of antenna that we're using, that we're installing in the RAN. But let's focus more on the BBU and the RRU. So here is the RRU. So it is more on the physical layer. So it's used for the radio frequency conversion. So we are converting analog to digital and vice versa, digital to analog. So the RRU is connected to the BBU via a front haul. So nadadagdagan na. So kanina we only have a back haul, but now we now have a front haul. So this BBU is connected to the RRU again via front haul, and this BBU, as you see, performs different tasks or protocols. So we have here, for example, RRC, PDCP, RLC, MAC, and physical. So in the RRC, or the radio resource control, it performs or functions as for broadcast, for paging, connection management, mobility functions, measurement configurations, reporting. Yeah, that's it. That's all the responsibility of the RRC. Next is we have here the PDCP, we call. It is the Packet Data Convergence Protocol. So it is more functions as for IP header compression, security, including ciphering and integrity protection. Next we have here is the RLC, or the radio link control. So it is for segmentation, concatenation, ARQ, duplicate detection. So next is we have the MAC, or the media access control. It is for multiplexing of logical channels, HARQ, channel mapping, packet scheduling, QoS. And lastly, we have the physical, which is for error correction, coding, redundancy checking, modulation, demodulation, resource element mapper, or the IFFT. So this is what the BBU performs inside a BBU. So now we will be jumping off some of the topics. We can always discuss some of the topics in the other sessions of the Asia Open RAN Academy, but now we are moving very fast and very quickly because we only have a limited time. We only have like for an hour only. Okay, so now we will be tackling now what is an Open RAN. So this will be the main focus of this series of webinars of the Asia Open RAN Academy. So, but before that, we have a different telco operator key challenges. So I think a lot of operators are really experiencing these challenges up to now. So first is the faster time to market. Okay. So in the faster time to market, we have a faster rollout for new features, services, and capabilities. So as I remember back in college, when I was in my internship in Manila. So one of my boss there told me that in telco there's every year there's a lot of changes that's going on. There's a new technology every year we're upgrading. So I think it's really applicable that there's a faster rollout for new features, services, and capabilities every year. So if we have a faster rollout for new features, we have a really significant investment in new networking technologies. So we need a lot of investment for it. So it's not just applicable to one operator, but all of the operators that's existing. And next is the flexibility. So next is what we have. One of the key challenges is better performance. So since there's an upgrade, there's always an upgrade or a development in the technology of the telecommunication in the telecommunication industry. There's an expand and improve in the system capacities. There's a big demand for better coverage. Big demand for enhanced quality of service that we give to different users, to the clients. So, which they deserve for what are they paying for. So next we have is uh, lower cost. So it's a major challenge because here we need to cut in energy consumption. So all of the equipments that existing in the radio access network really take a lot of energy. So it needs a lot of energy. But in the telecom field, we need to be business minded too. So every company in every work that we do in the industry, we need to also be business minded. We need to cut some of the expenses, or not just the expenses, but the consumptions or anything that we need to cut there. So we also lower equipment costs and reduce the capex or and opex. So it is the capital expenditure and ano yun? Operational expenditure. So it's very one topic that we always talk about in the industry. So there's this thing, the what do you call this formula for computing this capex, apex, opex. So there's a payback period, so you can just make a computation yourself. So if it's is the payback period is equals to capital expenditure over revenue minus the operational expenditure. So there you can see the payback or the return of investment in how many or how long will you get the return of investment the of the of the whole system that you installed in one site. So I think that's how we sum up the different key challenges that the telco operators usually experience. Here we have the worldwide global market shares. So it's quarter one of 2021. So it is the current traditional for the current traditional run. So you can see here different vendors that we have. So we have here Huawei with 29% shares, Ericsson with 15% shares, Nokia with 15% shares again too, and ZTE with 11% shares. And surprisingly, we also have Samsung with 3% share. Uh, Maybe most of you do not know that Samsung also has have a share in the telecom industry. So you can see here traditional RAN. So we have here the baseband unit, the RRU and the antenna, and the CPRI, the cables, and the different panel antenna. So this is what radio access network looks like in a simple illustration. So situation today, current RAN implementations offered by the incumbent vendors combine the equipment in an inseparably linked set of proprietary hardware and software components. So in the traditional RAN, we have what you call here, proprietary hardware or software components. So what do you mean by proprietary? So proprietary means this all of these components, in may it be hardware or software, is owned by one vendor. So it may be a Huawei who own this. It can be the RRU, the BBU is owned by it comes from Huawei. But if no, but if the RRU comes from Huawei and the RRU and comes from Ericsson, it will not work. So that's the challenges that we have in the traditional RAN. So that's the reason why we are studying the Open RAN. So the principle of the Open RAN. Open RAN is the manifestation of a broader technology move, so called disaggregation. which is observed in many years in IT industry. So it means it's already happening in the IT industry for many years. So what do you mean by disaggregation? So disaggregation is the splitting of the system into smaller subsystems. So later we will more discuss about this disaggregation of the hardware and the software. So it only means it separates the hardware and the software. So for Open RAN, we focus on the disaggregation of the radio access network components. So that's what been Sir Herbert been talking about earlier. That Open RAN is really focused with the disaggregation or separation of the different components of a radio access network. So in an Open RAN or in a disaggregated RAN, you can see here the core network is a traditional RAN and the user equipment. So this is what a traditional RAN in a figures in a diagram. In Open RAN, this is what will happen. So in an Open RAN network, we all see the core network is at least, but in the radio access network, we open the RAN. So what do you mean by we open the RAN? So the traditional or the BBU and the RRU is still the main components of the RAN. The BBU is split into two main parts. So the CU and the DU. So the CU is the centralized unit and the distributed unit. And you still have the RU and the user equipment. So again, to easily visualize what an Open RAN looks like or what it means by disaggregated RAN. So from the traditional RAN, again, we have the BBU and the RRU. So in the Open RAN, the BBU is split into two, which is the centralized unit and the distributed unit. So that's what happened in the Open RAN. So disaggregated again means we separate or we split. So take note of that. So that's very common words that we use in the Open RAN. So what does open means? So open, the main goal for using an Open RAN is to have an interoperability standard for RAN elements. That's just like what Sir Herbert told earlier that about Open RAN interoperability is to for the different vendors to operate with each for different vendors to operate interoperably. So open refers to the intentional capability of software, hardware, or interfaces to comply with an agreed upon standard. So there will be an open source for software, so it will be open. So there open source for hardware and open source for and open interfaces. So these three, the software, the hardware, and interfaces, this can be three different vendors. So it can be Huawei, Ericsson, and Nokia, or anyone or any vendor. So I think that's a good thing because we will not be limited for one vendor. Also, there will be just like what Sir Herbert told earlier again, that it opens a very good competition to a lot of vendors outside. So here, the Open RAN, or ORAN. So let's be clear with these three different terms. So Open RAN is a broad term to describe disaggregated RAN solutions built on an open COTS hardware and open interfaces standards. So it is the term that we use to describe this disaggregated RAN that we've been telling you. So next is the Open RAN. So it refers to the TIP project group. This is the one group that you will face later on, and concepts defined as vendor neutral disaggregation of RAN at both the hardware and software levels on general purpose and processor based platforms, and implementing open interfaces between components. So this concept includes virtualized and integrated RAN solutions. So again, Open RAN without the space refers to the TIP project group and concept. Lastly, we have the O-RAN. So it refers to the ORAN Alliance, which is an operator founded by the founded organization defining the standards for next generation RAN architecture and open interfaces to ensure interoperability. So they are the one who's defining the different standards for different RAN or the future of the RAN architecture with open interfaces para so there can be interoperability in the system. So what is an open RAN means? Open RAN means open radio access network. So take note of that again. So this is an industry movement that develops or disaggregated interoperable radio access network called solutions, leveraging general purpose processors, hardware, GPP hardware, software defined technologies, and open interfaces based on industry standard. So here you can see a simple illustration of what what Open RAN looks like. So we have here the different RAN. So in this RAN, there's the radio unit in each site. So another component of the Open RAN is we have the DU and the CU. Yeah. So in the DU, you will see the GPP hardware, the DU software, the DU hardware. In the centralized unit, there's also the same. And here is the core network. So the DU is connected to the RAN or to the RAN by a front hole or the RU by a front hole. The core network here is connected to the centralized unit by a backhaul. And the centralized unit is connected to the DU via a mid-haul. Okay. So there are different benefits for the Open RAN. So we have first is a diverse vendors ecosystem. Next is a more competitive supplier environment. Next is the fast network deployment. So it's very the word itself. So easy access to third-party software developers, automation. It's been a highlight of one of the highlights of what Sir Herbert been telling earlier. Artificial intelligence and machine learning, lower total cost of ownership. So it's because of the RU white box, the cost servers, the CI/CD. So next is the reduced time to market and time of deployment. A very good benefit of the Open RAN. And lastly, we have the reduced equipment maintenance cost because I think some of it will be software based. Next is the different Open RAN drivers. We have your growing network demand, the network virtualization, the artificial intelligence, machine learning, and big data, and the 5G use cases. So if you already learned 5G, you will see the different 5G use cases, which is the ENBB, MMTC, and the URLLC. So here, we aside from the RAN drivers benefits of the Open RAN, we also have different main challenges in the Open RAN. So the network performance is common concern regarding the Open RAN because it is the ability to match the performance of proprietary hardware platforms. So it must match or not just match but lampasan pa yung performance of the proprietary hardware platform. So it's the traditional RAN. So recent lab trials and live deployments address at the end of this module that proof that the Open RAN is meeting the performance objectives. Next we have here is the fault management. I think when something goes wrong in the network, isolating the component that is source of the problem can be more complex in an Open RAN environment. So I think to solve this challenge, network management tools have been developed by the Open RAN, contributing to root cause analysis and speedy issue resolution. Next is automation or the network automation. So I think to fully realize the benefits of Open RAN and to manage complexity, operators must invest in cloud management technologies and extreme automation including the orchestration and DTP or the zero touch provisioning. So next we have is the understanding of the Open RAN ecosystem. So since it's a new technology, we have a very challenge. It's a challenge to understand its ecosystem. So one of the big enhancements to Open RAN is the end of the vendor lockdown age. So we will have a interoperability nga in the Open RAN. So in the new Open RAN environment, many different new vendors are appearing to supply hardware and software for each element of the network. So for this reason, it's important that everyone involved is aware of all the new hardware and software that currently exists as well as of all the providers. So for this issue, several initiatives were born to help different companies or different organization departments to understand and begin in this journey. So one example nga is the Asia Open RAN Academy. So they've been playing a big role in the industry too for us to understand this technology or the Open RAN. Next is the new team profile. So in an Open RAN, the lines between the world of telecommunication and the world of IT are blurred. So what do you mean by blurred? It means I think for me there will be in the future of the Open RAN there will be a collaborative environment between the IT industry and the telecommunication industry. So it means I think if you're a telco industry, you need to attain IT skills, and if you're from the IT, it's a very good thing if you get telco skills, so you can have the best of the both worlds. So in the future of this technology, there will be a collaborative space of skills from both field, the telco and the IT field. So it is, I think, one of the challenges that companies will be facing is the adapting of their teams, their employees, and like learning this about this Open RAN. So we are moving on to the GPP hardware. So the first GPP hardware here is the low-cost radio access network or the white box hardware. So the white box hardware refers to computer hardware such as servers or networking equipment that is assembled using off-the-shelf components instead of proprietary parts. So typical applications of this white box hardware or the low-cost radio access network white box hardware is the ODU, the ORU, and the front haul gateway. So you can see here an example of front haul gateway. So here, for example, we have here the BBU. We have here a front haul gateway, and you can see here different cells, 8 RU cells. So the implementation of this is more of like the implementation of the indoor system or the small cell or the small cell. So we have a BBU, the RRU. I think it's for lump site solution. I think that's where we apply this kind of implementation. So next of GPP hardware is we have the SRS RAN or the software radio system. So this hardware is a free and open source 4G and 5G software radio. So it is an open source. So it can be for 4G and 5G, and it's software based. Next we have is the open air interface. So I think it's a public standard for connecting the hardware to hardware and software to software. So with regard to hardware, it implies that there is more than one brand of product that can be hooked up to the device with the open interface. So I think that's it. Next is it's very common in the telco industry, the USRP, so the Universal Software Radio Peripheral. So it's a range of software-defined radios and designed. So mostly this is used for radio frequency applications. So now we're moving on to the Open RAN ecosystem. So the Open RAN groups and initiatives. So there are these are the different groups who are studying or who are how do you say this who are handling the study or development of the Open RAN. So we have first is the Telco Infra Project or the TIP, the ORAN Alliance, and some other key Open RAN groups, which is the ORAN Software Community, Small Cell Forum, and the Open RAN Policy Coalition. So first we have is the Telecom Infra Project. So there are this the first of the two industry groups spearheading the Open RAN initiative. So TIB was founded in 2016 by Facebook, Meta, as an engineering-focused collaborative technique for designing and implementing global telecom network infrastructure with the objective of allowing universal access to the internet. So TIP is led by a board of directors comprised of founders from the technology and telecom industry. So this TIP Open RAN project group. So TIP is an international consortium of telecom equipment and software companies. So in this you can see here that the Open RAN project group is an initiative to define and build the 2G, 3G, 4G, 5G RAN solutions based on general purpose vendor neutral hardware and open interfaces and software. So these TIP members of companies host technology incubator labs and accelerators, and TIP hosts an annual infrastructure conference known as the TIP Summit. So there's this thing that they call the plug fest wherein they trying to connect each equipment or components for different vendors. So next we have is the ORAN Alliance. So the ORAN Alliance, which was formed in February 2018 with the goal of promoting open and intelligent RAN. So they have a goal to promote open and intelligent RAN. It's the second organization driving the Open RAN movement. It was created by merging the two organizations. So these two organizations are the China Mobile and other mini Chinese vendors. So the CRAN Alliance. This one is the NTT, Docomo, and other mainly American vendors, which is the XRAN Alliance. So again, they are created by merging the two organizations. This is the CRAN and the XRAN. So then there we have the ORAN Alliance. So founding operators of this alliance is AT&T, China Mobile, Deutsche Telekom, NTT, Docomo, and Orange. So the ORAN Alliance is a group of telecom companies that aim to improve the performance and openness of their networks. They call for more intelligence in network through the information collection of these virtualized network elements. AI and machine learning can be applied to this collected information. So I think the Orange Alliance has an important role in bringing the industry together to create more software-based, virtualized, flexible, intelligent, and energy-efficient network. So high-level goals of the Orange Alliance is the openness, so enabling small vendors to introduce their own service. Next, plus the open source reference design, so enabling faster and permissionless innovation. And the second goal is to automate complex networks. So it means by simplifying operation and maintenance and enabling a new era for network operations. So I think this openness will bring service agility and cloud scale economics to enable small vendors and operators to introduce their own services or customize the network to suit their own unique needs. So open interfaces enable multi-vendor deployment. So this is the goal. And enabling a more competitive and a vibrant supplier ecosystem. So this is something that Sir Herbert been telling all throughout his discussion earlier from the Open RAN interoperability. Okay, so next we have here is the ORAN technical groups. So here we have a different part of the ORAN. So we have the orchestration and automation, the RAN intelligent controller or the RIC. Here is the RIC again, the COTS platform, virtualization layer, and the COTS platform, ODU, ORU. So these are the different parts of the ORAN architecture. So here is a simplified illustration of the ORAN architecture, where is the core network uh, is the in the OCU. So here is where we will find the core network. So I think this is very here we have the organization framework, the near time, real time RIC, OCU, ODU, ORU, and OCloud. So that is to show you a simplified illustration of the ORAN architecture. So most of this will be focused on the next sessions of the Asia Open RAN Academy. So these are different operator members for the ORAN Alliance membership. So let's take a closer look. So we have here Bell, China Unicom, Telefonica, Rakuten Mobile, Vodafone, Verizon. Here is the different ORAN Alliance contributors and academic contributors. So we have a lot of contributors and academic contributors. So the ORAN Alliance is open to different mobile operators, vendors, or research and academic institutions that really want to contribute a meaningful way to the ORAN Alliance effort. So it is a collaborative way of discovering this new technology and enhancing it and enhancing to enhance more this kind of technology. So TIP versus ORAN Alliance. So sometimes it may be confusing as the road to each of these two organizations based in the industry. So here's a really quick breakdown of the leading Open RAN organizations. So here here is the TIP Alliance, TIP. So the TIP group. The TIP group is more concerned with deployment and execution. So yun nga, yun sinasabi ko kanina, they promote plug fests and live deployments in the field. Also, TIP allows the Open RAN ecosystem, guarantees that different suppliers, software, hardware, and equipment works together. So this is where the interoperability enters. So it is in charge of use case productions, facilities trials, field testing, and deployment. TIP is focused on solutions across all generations of the mobile communication, which is the 2G, 3G, 4G, and 5G. So while on the other hand, here is the ORAN Alliance. So they create, promotes, and enforces standards to guarantee that the equipment from various suppliers may communicate with one another. So they are the one who's doing the promotions and the standards. Next is they develop standards where none exist, such as the front haul requirements. So just like what I've said, they're the one who's creating the different standards for these technologies. So it also generates profiles for interoperability testing when standards are available, such as the X2 interface. And ORAN Alliance is mainly focused on the 5G and the 4G solution. So these are the difference between the two organization that plays in the industry. So to show you, there is the ORAN software community. So here is the different collaboration between the ORAN Alliance and the Linux Foundation with the goal of promoting the development of the open source software for the RAN. So the mission here is to enhance the openness of the radio access network. They focus on open interfaces and followed by the implementations that utilize new capabilities allowed by the ORAN standard. So that's it. So the other key Open RAN groups here is the ONF, or the Open Networking Foundation. So the ONF is an operator-driven, community-led non-profit consortium fostering and democratizing innovation in software-defined programmable networks. So one of their product here is the SD-RAN. So it's building open source components for the mobile RAN space. complementing the ORAN's focus on architecture and interfaces by building and trialing ORAN compliant open source components. So this is one of their products. So next is we have the SCF. So the Small Cell Forum or the SCF has developed its own Open RAN environment with small cells in mind. So they have recently placed a strong emphasis on developing open interfaces, but this is different from the small cells that that's being implemented, but they have, I think, same principle. So in this SCF, they're implementing a split 6 option. So hinahati niya si Mac and si physical layer. So dun yung focus niya nung ating SCF. So Open RAN Policy Coalition. So the Open RAN Policy Coalition is a collection of peers created to support policies that would accelerate the adoption of open and interoperable solution. So in the RAN, as a method of creating innovation, stimulating competition, and expanding the supply chain of advanced wireless technologies such as the 5G. So that is for the Open RAN Coalition. So they have different goals. So first goal of this Open RAN Policy Coalition is to fund research and development. Next is to remove barriers to 5G deployment. Avoid heavy-handed or prescriptive solutions. Use government procurement to support vendor diversity. Signal government support for open and interoperable solutions. Support global development of open and interoperable wireless technology. So they are supporting terms of policy, and also they are encouraging to give incentives for the operators to deploy or implement this Open RAN technology. So these are the different deployments and trials of the Open RAN. So first we have is coverage and extension site densification. So here the deployment scenario here is the RAN sharing or the interoperability of the full RAN. Next is the new deployments in urban and suburban solutions. I think in the new in this scenario, we just like what I've told you, that in telecom industry, there's yearly we upgrade. We are leveling up always and changing a lot in the industry, or how do you call this? There's always a new technology that's about to come. So we always we always have new deployments in every site or in every area. It may be in urban or suburban solution. So next is the system replacement and upgrades. So it is more on the change out rollouts of these new technologies. Rural coverage, support private and neutral host networks. So what do you mean by support of private and neutral host networks? So it means like, for example, you wanted to have a or your own radio, you can buy a slice of a network, a slice of a technology in the operator. So you can now have a piece of that radio that you wanted. You can solely own that network, and no one has the access to that network, but only you who own that network. So you can buy a slice of it. So there are different deployment and trials that's been made by the different vendors and companies. So the AT&T in USA, we have AT&T, Verizon, and T-Mobile. So trials, but there are no commercial deployments yet. There are no commercial deployments yet. So in Germany, we have Deutsche Telekom in partnership with VMware, Intel, and others. In Japan naman, we have Rakuten. So in greenfield 4G deployment. And next we have China, all members of the ORAN Alliance and have tested the Open RAN. So it's a very good thing. again in USA, the Dish. So it's a new player to deploy the Altio Star and the Manager Open RAN. So they're in help with Fujitsu radios, Fujitsu radios. So the MTN naman, so announced Open RAN with Parallel Wireless in 21 developing MEA countries. Lastly, in UAE, we have Etisalat. So I'm very not familiar with it, and Vodafone and Telefonica, probably the leading exponents. So to map it out, the deployments and trials of the Open RAN, we have here parallel wireless at Turkey. So they integrated 2G, 3G Open RAN solution with vendor parallel wireless to 25 semi-rural areas. So their objective is to improve existing 2G and 3G connectivity and add LTE and manage all from a single virtualized RAN controller. So this is what happened in Turkey by parallel wireless. Also in DRC, or the Democratic Republic of the Congo, Mozambique, Ireland, and UK, we have two main vendors, the parallel wireless and the Mavenir. So they also did a lot of trials using the Open RAN system. And we have also trials in India by Mavenir and Vodafone. So there are a lot of vendors, companies, and contributors who do or deploys a lot of trials for us to enhance this Open RAN system. So another one is in Colombia and Peru and Argentina. So also by parallel wireless. And here in Brazil, Germany, Spain, and UK, Telefónica, Intel, Gigaterra, Altiostar, Supermicro, Xilinx, Mavenir, and Wave Mobile in Brazil, Germany, Spain, and UK. So there's a lot of vendors that are really trying to deploy this Open RAN technology. So this is the vendor ecosystem. So the traditional vendors are more or less reluctant to embrace the full concept. Most reluctant have the highest market value. So these are the companies that are the traditional vendors. So the Nokia, Ericsson, Samsung, ZTE, Huawei. So in the radio subsystem vendors, we have here the NEC, the Mavenir, KMW, and the Parallel Wireless, Altiostar, and Fujitsu. These are the Open RAN pure players. They are deploying a lot in the US, Japan, Korea, Taiwan, and pushing strongly. So integrators are also preparing to extend their market to the RAN integration. So these integrators are the Tech Mahindra, Amdocs, and Radisys. Large chipset vendors are investing too heavily to enable the infrastructure compliant with RAN requirements. So hyperscales are preparing their infrastructure to support the RAN. So we have Google, Windows, NVIDIA, Qualcomm, Intel, and AWS. So in this Open RAN vendors, so the challengers is very, very much committed to implementing this Open RAN is the Mavenir, Parallel Wireless, and the Altiostar. And the vendors are the Huawei, Nokia, Ericsson, Samsung, and ZTE. So the challengers, they have a different contribution since they are very committed in deploying the Open RAN. So the Mavenir contributed end-to-end portfolio of the mobile network BNF and CNF's core to RAN. On partner ecosystem, they act as an integrator to deliver multi-vendor solutions. Their telco partners in this commitment is the Vodafone, Telefonica, Dish, and Turkcell. So while in the parallel wireless contributes the focus on supporting all mobile radio generations and classes of radio via centralized, virtualized, and Open RAN controllers. So if you will go back to like knowing the RAN or the radio access network, so we have different types of RAN that which are not discussed, but you can always search it on the internet. These different types of RAN. There's multiple Open RAN use cases, so multi consolidation, Open RAN as software overlay to boost capacity, and these deployments and trials are in partnership with Vodafone again, Telefonica, MTN, Orange, and Etisalat. So lastly is the Altio Star. So they're contributing the Open RAN software provider, wide range of partners, and involved in some leading deployments and trials, including the Rakuten, Telefonica, and Dish. So both Rakuten and Telefonica have made equity investment in Altiostar. So this is the Open RAN vendors. So we have here the Ericsson, Huawei, and ZTE. No Open RAN elements in the current portfolio, but E and Z are contribute to ORAN. So they're contributed to the ORAN Alliance. So Samsung and Nokia announced new products incorporating with Open RAN elements in June and July of 2020, I guess. So these are the arguments that offered by the incumbent vendors. So single vendor integrated BBUs and radios guarantee carrier grade performance and reliability, some which they claim cannot be guaranteed with Open RAN. So it is issue to these vendors. So 2vRAN platforms are only semi-virtualized, claims this offers the benefits of virtualization without the risk associated with fully disaggregated solution from one more or vendors. So smoother upgrade to 5G, while Open RAN is not mature for 5G macro network, and using new Open RAN vendor just is for 5G is problematic, would require expensive custom integration and development. So there are a lot of arguments still that is going on with Open RAN, but I think this will soon about end, especially if Open RAN will be implemented in the country. So this is a players with most announced contracts in the Open RAN. So we have here the Parallel Wireless, Altiostar, and the Intel gaining the most the top spot for the contracts with Open RAN and the others. So I'm almost at the end of this discussion. Since there are a lot of key topics that are not discussed, so we will try, I think, to discuss it in other session, since we don't have a lot of time for that. So the supposed to be a key learning point is that the RAN means radio access network. So we already discussed it. So RAN is a part of a cellular mobile network that gives mobile coverage. Open RAN means Open Radio Access Network. Open RAN is an industry movement to develop disaggregated and interoperable radio access network solutions using the GPP, software-defined technologies, and open interfaces. So these are the different main driving forces of the Open RAN. The 5G use cases, artificial AI, machine learning, big data, network virtualization, and growing network demand. The benefits of the Open RAN. The Open RAN most crucial challenges and ensure deployment readiness in the system integration. The two major RAN groups and initiatives are the TIP and the ORAN Alliance. Open RAN deployment scenarios are site densification, coverage, extension, greenfield deployments in urban and suburban systems, replacement, upgrade, rural deployment, and support of private and neutral host networks. Open trials and deployments have been done in different parts of the world.